In this video, we begin the third part of our module, the last part, which is about vectors. Let me give you a brief introduction to vectors. So vectors are quantities which have both a magnitude, a length, and a direction. You have all seen vectors by now. So for example, in physics, you have seen that objects that are moving have a velocity, which is to tell you in which direction is the object moving and at what speed is it moving. But force is another example of a vector. Acceleration is also a vector quantity. So, but of course, not all quantities are vectors. Just think of the mass of an object, which is specified by a single number, or think of temperature is again just a single number. It has no direction. So let me just write it down that by definition, a quantity is called a vector if it has both a direction to it and a magnitude. Or length, in other words. Okay, we'll use the following notation for vectors. If we want to talk about the vector v, what we'll do is we'll put a little arrow above the letter v. And this is how we make sure that we remember that this quantity is a vector quantity. Of course, vectors are specified or can be specified by giving the initial point and the end point of a vector, basically telling us from which point to which point is it pointing or going. So a vector can be specified by its initial and end points. So this, for example, is a vector that I'm drawing here, is a vector that is pointing from A to B. If a vector is specified by its initial and end points, then we might want to use that in the notation. So we might write that it's a vector from going from A to B. Okay, so this is also a vector. Of course, there are other types of, there could be a case where we want to fix the initial point of our vectors and use the endpoints to locate points in space or in a plane. So in that case, we talk about position vectors. So for example, if we distinguish a point in the plane, we would have position vectors. So that is what we have when we have a coordinate system. So let me just sketch a coordinate system for you. We pick a special point that is the origin, and if we want to specify points in the plane, for example, we would draw a vector to it, to a point P from the origin. Okay, so, and we would say that this point P might have some coordinates P1 and P2, but that red vector going from O to P would be the position vector OP with a little arrow on top. Okay, so to give you some examples of vectors, where can we meet or use vectors? Well, we've already have used vectors. For example, when we had the complex plane and used it to locate or represent complex numbers as points in a plane. So complex numbers are basically located in a complex plane. Are exactly examples of position vectors. So let me say that this way of writing or visualizing vectors is called position vectors. But there is another way to use vectors, and that is to, for each point in a plane or in space, we would like to assign a velocity to that point. So think of a wind map, for example. So you've all seen in your weather forecasts that there is the map of a country, and for each point, each place in that country, there might be a little arrow pointing in some direction in which the wind is blowing, and there might be a number specifying the wind speed. So that would be the magnitude of our vector. So wind maps are examples of velocity vectors. Okay, so what happens here is we have a map, and on that map each point has a vector assigned to it. Okay, so to finish the video, I would like you to look at this vector AB, which I have drawn at the beginning of the video, and I would like you just to test your understanding to decide which of the following vectors is equal to it. Remember, a vector is given by its direction and its magnitude. It's only these two things that matter. So is it perhaps this vector, vector A, that is equal to vector AB, or is it vector B that is equal to vector AB? Maybe it's this one, vector C, or could it be the next one I'm drawing, which is vector D? So which of these vectors do you think looks most like our vector AB? Okay, pause the video and select your answer in the from the options below. Okay, I hope you paused it and have chosen option B, because all we care about when we look at vectors is to have the same length, and this vector indeed, well, roughly has the same length and the same direction. So these vectors, if I just take this vector and shift it through, so they overlap, they perfectly overlap, and they have the same direction. Okay, so it was vector B that was equal to AB. Okay, I hope you enjoyed this video, and I'll see you in the next one.